To attempt the question above, the first thing to do is to write out the chemical equation involved as stated in the question. So let's do that. Looking at the equation above, we discovered it is a balanced chemical equation. So there is no need to worry about the balancing. So that has been done. So let's proceed. In the question, we are to determine the number of molecules of carbon dioxide produced, and to determine the number of molecules we need to know the number of moles of carbon dioxide, that is CO2, that was produced. Going further, in the question we are given the mass of calcium carbonate that was treated with hydrogen chloride. The volume of hydrogen chloride used was also given. But one thing I would like us to take note of in situations like this, in which we are given information about both the acid and the base in the question here, or let me just say we are given information on both reactants involved, we need to note that the substance we are working with, that is when we are being asked to calculate, that's CO2, where is it gotten from? That is the reactants that initiate its production. And looking at it, the product here is CO2, and we have CaCO3 and HCl. There is no way HCl will yield CO2. That's not possible. But CO2 can be gotten from the breakdown of calcium carbonate. So the information we'll be needing will have to do with that of calcium carbonate alone. That means the value given or the information given about HCl will be neglected. So we have nothing to do with the statement of 0.2 dm cube of 1 mole of HCl. In case you might be confused that why didn't we make use of 0.2 dm cube. So having said that, I'll proceed with the solution. Mind you, we need to determine the number of moles of CO2 first before we find the number of molecules. And to know the number of moles of carbon dioxide produced, we need to calculate the number of moles of calcium carbonate that was used. For calculating moles, the formula is moles equals mass divided by molar mass. For calcium carbonate, we've been given the mass in the question, that's 10.0 gram, but we do not know the molar mass yet. So let's calculate the molar mass of calcium carbonate. We can also refer to it as calcium tricarbonate. For molar mass, that's the sum of the atomic mass of the elements present. So that's calcium is 40, carbon 12, oxygen 60, and we have 3 atoms present. 3 times 16, so this is equivalent to 100 grams per mole. For the number of moles, let's substitute our values. From the question, the mass is given to be 10.0 grams and the molar mass 100 grams per mole. So calculating this, we have 0.1, the unit moles. The number of moles we've gotten here is for calcium carbonate, and mind you, we are working on carbon dioxide. So from the equation here, let's come back here. 1 mole of calcium carbonate will yield 1 mole of carbon dioxide. So if we have 0.1 mole of calcium carbonate, equal amount of carbon dioxide will be produced as well. So here I can just state that the number of moles of carbon dioxide produced is 0.1 mole. To solve the number of molecules, we'll make use of the formula saying number of entities equals moles multiplied by Avogadro's constant. The entities could be atoms, it could be particles, it could be ions, it could be molecules. In the question here, we are dealing with molecules. So here I will say number of molecules of carbon dioxide equals the number of moles, we've gotten that to be 0.1, multiplied by Avogadro's constant, which is 6.02 times 10 raised to the power 23. And calculating this, we have 6.02 times 10 raised to the power 22, the unit molecules, and this will be serving as the final answer. So with this, we've come to the end of the solution to the question, and we've gotten the number of molecules of carbon dioxide produced to be 6.02 times 10 raised to the power 22 molecules. That will be all. Do well to subscribe for more if you find this video helpful.